Graphing sine, background, and vocab. The equation for sine is a times sine, parentheses b times theta times c, plus d. A is the amplitude. 2 pi divided by b is the period. D is the midline, and c divided by b is the phase shift. How do we use these terms for graphing sine? The midline runs across the y-axis, and it's used as a reference line about which the graph varies in position and magnitude. The amplitude is two dotted lines representing the minimum and maximum of a graph. It stretches upward and downwards from the midline. For example, if a equals 2, the lines would go up and down from the midline 2 places. The period is the distance the function needs to complete one full cycle. It helps to give us the points we plot on our graph. A phase shift is the horizontal shifts of the points on our graph. For example, if we have pi and the phase shift is 2 pi, our final answer is 3 pi. For example 1, we have a very simple equation, 2 sine parentheses 2 times theta minus 3. Now it's time to find our amplitude, midline, and period. We don't have a phase shift in this problem. The amplitude is the number in front of sine. In this case, it's 2. The midline is the number outside the parentheses, which in this case is 3. The equation for period is 2 pi divided by b, so in this problem, the period is pi. To make our table to help plot our points on our graph, we need to figure out the origin, our period over 2, and the period itself. Now we put them in a horizontal line, and on the side we write old, meaning our original equation, and new, which means our new equation. The origin for the old equation is always 0, and in this equation, our p2 is pi over 2, and p is pi. Since we don't have a phase shift in this problem, we will not have a new equation. Now we rewrite our amplitude, midline, and period, as well as drawing a simple graph and writing down our points. Now we write the 3 points on our graph, leaving a space between each as we will need a point there eventually. Now it's time to draw our midline. In this equation, we go up 3 on our y-axis and draw a horizontal line. We will be putting our main 3 points on that line. Next, we draw our amplitude. In this problem, we go up and down 2 from our midline. Finally, we plot our points. We put the 3 we found using the table on the midline, and in between the first and second, there is a point on the upper amplitude, and in between the second and third, there is a point on the lower amplitude. In example 2, our equation is more complex. The problem is 3 sine parentheses 2 theta plus pi parentheses plus 2. Now, like always, we find our amplitude, midline, period, and now we have to find a phase shift. By looking at the problem, we know the amplitude is 3 and we know that the midline is 2. Using simple math, we know our period is pi. By dividing c by d, we get pi over 2 for our phase shift. After we labeled the table, we put 0, pi over 2, and pi for our old equation. Because our phase shift is pi over 2, we are going to add that to all of our old equation answers, giving us pi over 2, pi, and 3 pi over 2. Now we again rewrite our amplitude, midline, period, and phase shift. Then we draw a simple and neat graph, as well as redoing our table. Make sure to use the new equation to plot your graph. Then proceed to draw the midline, amplitude, and all of your points. Don't forget to smoothly connect them, and you're finished. Our final and toughest equation is 2 sine parentheses theta over 2 plus pi over 2 parentheses plus 3. The next step is, of course, to find our amplitude, midline, period, and phase shift. Our amplitude is 2, our midline is 3, the period is 4 pi, and the phase shift is negative pi. Next, we fill in the table. The old equation is 0, 2 pi, and 4 pi, and the new equation is negative pi, pi, and 3 pi. Now it's time to graph. Make sure to carefully complete all the steps to correctly graph this function.